The Secret Code of Science. Alara and Kale were ready for the championship baseball game, but a sudden thunderstorm sent everyone running for cover. "This isn't fair," Kale sighed, watching the rain soak the field. Dr. Eris, their science teacher, sat down beside them. "In science, we call rain an unexpected variable," she explained. "Just like in a game, if too many things change at once, like the wind, the wet grass, and the slippery ball, it's impossible to tell which team is actually better. To find the truth, we have to limit those variables, so we only test one thing at a time." Back in the classroom, Jory joined them as Dr. Eris grabbed a marker. "To be a scientist, you must master the variables," she said. She wrote independent variable on the board. "This is the one thing you deliberately change to see what happens." Then she wrote dependent variable. "This is the outcome, the thing you measure to see if your change worked. If you change the amount of sunlight a plant gets, the independent, the height it grows is the outcome, the dependent." "But how do we know our change really caused the result?" Alara asked. Dr. Eris showed them a chart about a famous study on insulin. "We used two groups," she said. "The experimental group gets the new treatment, like the insulin. The control group stays exactly the same, so we have something to compare it to. This is how scientists studied how smoking affects lung capacity. They compared people who smoked to a control group of non-smokers to see the real difference in their health." Kale looked puzzled. "What if the people in the control group just think they feel better?" Dr. Eris nodded. "Great point, Kale. That's why we use a placebo. In the insulin trials, the control group might get a sugar pill that looks just like the real medicine. Since they don't know which one they have, their minds can't trick the results. This keeps the experiment blind and the data honest." "Before we start, we need a hypothesis," Dr. Eris said. "It's a specific prediction written as an if-then statement. Alara tried one. If the temperature drops in autumn, then the leaves will change color." Kale added another. "If we use high-friction rubber on tires, then the race car will stop faster on wet tracks." Dr. Eris smiled. "Exactly. Those are testable. You are predicting exactly what X will do to Y." Sometimes, a hypothesis needs refining. Jory suggested, if a person wears a lab coat, then they will be better at math. They tested it, but the results were all over the place. The lab coat didn't change their brain, Jory realized. Alara helped him fix it. "If we want to test professional clothing, we have to be more specific about what we are measuring. Maybe it's not math skills, but how much people trust the person speaking." Next, they practiced measuring. Dr. Eris set up a beanbag toss. Kale threw 3 bags, and they all landed in the exact same spot, but far away from the bullseye. "That's precision," Dr. Eris said. "You are consistent, but you lack accuracy, which is how close you are to the actual target." Jory threw his bags, and they landed all around the bullseye, but none were near each other. "You have low precision, even if one was accidentally accurate." "Errors can happen in 2 ways, Dr. Eris explained. "A systematic error is like a scale that is always 5 pounds off. It ruins your accuracy every time. A random error is like a shaky hand while holding a stopwatch. It's unpredictable." Alara checked her timer, so if I'm not precise, I might just need a steadier hand. But if I'm not accurate, my tools might be broken. "What if our results are still confusing?" Kale asked. Dr. Eris gave them a checklist for modifying their design. 1. Re-evaluate the question. 2. Look for hidden variables. 3. Fix the hypothesis. 4. Check your tools for accuracy. 5. Test more people for a bigger sample. 6. Control the environment better. 7. Ask a friend to peer review your work. Science is all about trying again. By the end of the day, the sun came out. Alara, Kale, and Jory felt like real scientists. They knew how to spot variables, form a hypothesis, and measure with precision. "The world is full of questions," Dr. Eris said, "and now you have the tools to find the answers." Alara smiled, holding her notebook tight. Next time it rains during a game, I won't just complain. I'll start an experiment.